Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children. Right. Yeah. So I think we finished this one in the last class. So tell me, complete these two identities, children. What is A minus B the whole cubed? What is A minus B the whole cubed? And what is A plus B the whole cubed? A minus B the whole cubed is equal to A cubed. Yeah.
Minus B cube.
Minus B cubed. A cubed minus B cubed.
3a square b plus 3a square b.
Minus 3a square b plus 3ab square. And a plus b the whole cubed is a cubed plus b cubed plus 3a square b plus 3ab square. So these were the two identities we used here in answering question number 5. I think we finished this also in the last class, right? Please tell me if we finished. Yeah, we finished this in the last class.
Ma'am, we completed till sum.
This one? No, I think I explained this one in the last class. Okay, so here if cos theta plus sin theta is equal to root 2 sin theta, show that sin theta minus cos theta is equal to root 2 cos theta. So I was telling you that here you can see something like a plus b, cos theta plus sin theta. Here, okay, so treat this as, since we have to find sin theta minus cos theta. Since we have to find sin theta minus cos theta, you treat this as sin theta plus cos theta. You treat this as sin theta plus cos theta. Okay, it's the same, no? Cos theta plus sin theta plus cos theta, both are the same. So you're given sin theta plus cos theta, and you have to find sin theta minus cos theta. So I said make use of the identity a plus b the whole square plus a minus b the whole square is equal to 2 of a square plus b square. A plus b the whole square plus a minus b the whole square is equal to 2 of a square plus b square. Now, for a, use sin theta, and for b, use cos theta. So use this algebraic identity, and in place of a, use sin theta, and for b, use cos theta, and rewrite this identity. So a is sin theta, b is cos theta. So it will be sin theta plus cos theta the whole square plus a sin theta, b is cos theta. So sin theta minus cos theta the whole square is equal to a square plus b square. So a is sin theta, so a square will be sin square theta, and b is cos theta, so b square is cos square theta. So this is what we have when we use this identity. Now continue. What is given? What is given to you? You're given that sin theta plus cos theta is root 2 sin theta. So substitute sin theta plus cos theta is root 2 sin theta, the whole square, because square here, square here. This is what we have to find. Write it as it is equal to 2 into 1, because sin square theta plus cos square theta is 1 by the identity. So 2 into 1. Now square this, you get 2 because root 2 square is 2. And sin theta, the whole square is sin square theta. Write this one as it is equal to 2. Now transpose, because you'll have to find this, right? So take this one to the other side. You have to find this. So what do you get? Sin theta minus cos theta, the whole square is equal to 2 minus 2 sin square theta. And we know that whenever there's something common, take out the common factor. So 2 is common, take it out. In the bracket, you have 1 minus sin square theta. But we know that 1 minus sin square theta is cos square theta. We know that 1 minus, so you can include one more step. So you have sine theta minus cos theta, the whole square is equal to 2 cos square theta. 2 cos square theta. So sine theta minus cos theta is equal to square root of 2 cos square theta, which is cos square theta comes out of the square root as cos theta. 2 remains under the square root. So sine theta minus cos theta is equal to root 2 cos theta. And that's what we have to prove. Right down, children? Yeah, please write down. And the identity is a plus b the whole square plus a minus b the whole square is equal to 2 of a square plus b square. Why we use this identity is because we are given something like a plus b, sine theta plus cos theta, and we have to find the sine theta minus cos theta. So like you're given a plus b and you have to find a minus b. So we use this identity in which these expressions are connected. Yeah, right on, children. Done, children?
One minute.
Yeah. Finish, children?
No, ma'am.
Okay. Okay. Yeah, now it's over, right? Finished writing?
Yes, ma'am.
Yeah,
Yes, ma'am.
all right. Oh, I think we did this in the last class. Okay, I was confused. Maybe we finished this in the last class.
Yes, ma'am.
Yeah, yeah. So that's what I remember explaining something like that. Fine, fine. All right, children. Well, that's what I think Harini told me. We finished till the 7th one. Now see this one. If tan theta plus sine theta is equal to m and tan theta minus sine theta is equal to n, you have to prove these results. Okay. So see here. Yeah. So tan theta plus sine theta is m. So the m is equal to tan theta plus sine theta. N is equal to tan theta minus sine theta. and we need to prove that m square minus n square is equal to 4 root mn. 4 root mn. So now this is in the form a plus b. Can you see this? Tan theta plus sine theta, a plus b. Tan theta minus sine theta, a minus b. A plus b, a minus b. Okay, let's take up the LHS. What's the LHS? M square minus n square. This is the LHS. M square minus n square. We need to work the LHS. We need to work the LHS and maybe we can arrive at the RHS. If that's not possible, work the LHS, work the RHS and get this. You should show that you have the same answer in both. Okay, so first take up the LHS. M square minus n square. What is M? Tan theta plus sine theta. See here, tan theta plus sine theta. M square, so square. Minus, minus, minus. N. N is tan theta minus sine theta. Whole square because n square. So write m, n and square them. Okay, so that's the first step. Now children, this identity. A plus b the whole square minus a minus b the whole square is equal to 4ab. Now this is like a plus b the whole square minus this is like a minus b the whole square. So a plus b the whole square, because see here tan theta a, sine theta b plus minus. So clearly it's of the form a plus b the whole square minus a minus b the whole square, which is 4ab. Which is 4ab, that is 4 tan theta sine theta. That's what you see here, 4ab, 4 tan theta sine theta, because a is tan theta, b is sine theta. So 4 tan theta sine theta, so using this identity. Now we have this. We have this for the LHS. Take up the RHS now. Take up the RHS 4 root mn, 4 root mn. So that means 4 root mn. This is m, tan theta plus sine theta. This is n, tan theta minus sine theta. M into n. See here, mn meaning m into n, m into n. All right. So now this is the form a plus b into a minus b. So a squared minus b squared. Tan square theta minus sine square theta. Now we know that tan square theta can be written as sine square theta by cos square theta. Tan square theta, sine square theta by cos square theta. And we also know that whenever there is something common, we need to bring out the common factor. So you can see that sine square theta is common in the numerator. So bring it out. So you have in the bracket, this is common outside. So you'll have 1 by cos square theta minus this is outside common. So 1. 1. See, you've taken out sine square theta, which is in the numerator as common. So this is the outside. So it will be 1 by cos square theta minus this one is also common outside. So 1. 1 by cos square theta minus 1. Now see what we should get. Okay, you see what we should get. We should get 4 tan theta sine theta. We need to get 4 tan theta sine theta because that's the LHS. Okay, so now 4 into root of we are here. We took out sine square theta common. Sine square theta common and we have this in the bracket. Now to proceed, we know that 1 by cos square theta is secant square theta. You can also take the LCM, children. I'll tell you that also. We can also take the LCM. I'll tell you that also. Now, so 1 by cos square theta, reciprocal ratio, secant square theta, minus 1. And secant square theta minus 1, identity. Secant square theta minus tan square theta is 1. So secant square theta minus 1 is tan square theta, identity. So sine square theta, and by the identity, this is tan square theta. And both of them are perfect squares under the square root. Both of them are perfect squares under the square because see, sine square theta into tan square theta. So they undo each other. The square and the square root, they undo each other. And yeah, so we have 4. 4 is outside the square root. So sine square theta comes out as sine theta and tan square theta comes out as tan theta. But just so you can see that the LHS is equal to the RHS, hence 2. So you can also take the LCM here, children. 1 by, so what's the LCM? Cos square theta is the LCM. Cos square theta is the LCM. So you will get 1 minus cos square theta. You will get 1 minus cos square theta, children. If you take the LCM, you will get 1 minus cos square theta by cos square theta. 1 minus cos square theta is sine square theta. 1 minus cos square theta, sine square theta. Next step, sine square theta. And we know that sine square theta by cos square theta is tan square theta. See here, tan square theta. Sine square theta by cos square theta is tan square theta. So anyways, you will get the same thing. You can even take the LCM, children. You can take the LCM or you can also do it like this. If you take the LCM, it will be I'll work only for that bracket. So you will get 1 minus cos square theta by cos square theta. And in the next step, that bracket will be sine square theta, because 1 minus cos square theta, sine square theta by cos square theta. Next step, sine square theta by cos square theta will become tan square theta, which is what is here also. Yeah, I don't want to continue talking and bug you children. So please write down this. We'll see the second part. Please write down this. Done, children?
No, ma'am.
No. Okay. All right. You are done, children?
Yes, ma'am.
Yeah.
Yes, ma'am.
Now the second part. Good. Now the second part. We need to prove that m square minus n square, the whole square, is equal to 16mn. So take up the LHS again. M square minus n square, the whole square. Substitute the expressions for m and n. So this is m square minus this is n square. You can see m square minus n square, the whole square. So again, the whole square. So substitute very carefully. Don't miss out on any squares. Now again, identity. A plus B whole square minus A minus B whole square. What is it? What is A plus B the whole square minus A minus B the whole square? 4AB. So it'll be 4AB. A is tan theta and B is sine theta. Okay. So 4AB, 4 tan theta, sine theta. And you can see the square outside here. This is A plus B the whole square minus A minus B the whole square. This one is 4AB, 4 tan theta, sine theta, and the square here, whole square. So when you square it, 4 square is 16, tan square theta, sine square theta. See, like if you have A, B, C the whole square, it's A square, B square, C square. Similarly, we have 4 tan theta, sine theta, the whole square. So it will be 16 tan square theta, sine square theta. So that's about the LHS. Now take up the RHS, which is 16 mn. 16 mn. So 16 mn. So clearly this is A plus B into A minus B. So immediately A square minus B square. A square minus B square. So next what to do? What to do? So we'll write tan as tan in terms of sine and cos. Tan square theta is equal to sine square theta by cos square theta. And again, wherever there is something common, please take out the common factor or the common expression. So to proceed, we write tan square theta, sine square theta by cos square theta, because that's what we normally do. When we have other ratios, we convert it to sine and cos. So we write tan square theta, sine square theta by cos square theta. Now, whenever there's something common, we bring it out. So sine square theta is common, we bring it out. And in the bracket, we have 1. This is 1 by cos square theta minus 1. 1 by cos square theta minus 1. So 16 sine square theta into, I told you, you can either take the LCM or you can write 1 by cos square theta, secant square theta minus 1. And secant square theta minus 1 is tan square theta by the identity. So 16 sine square theta, tan square theta. Here also we have 16 tan square theta. It's just exchange, you know. This is 16 tan square theta, sine square theta. This is 16 sine square theta, tan square theta. Both are the same. So LHS is equal to RHS. Yeah, children, please work this. Done, children?
No, ma'am.
Okay.
Completed.
Yeah. We didn't finish this. Yes. Yeah. So see here, if L is equal to cosecant theta minus sine theta, and M is equal to secant theta minus cos theta, prove that L square M square into L square plus M square plus 3 is equal to 1. So again, whenever possible, if possible, you can simplify. So now let's try. We have L is equal to cosecant theta minus sine theta. So we can write cosecant as 1 by sine theta minus sine theta. Okay, so that will be 1 minus sine square theta by sine theta. And 1 minus sine square theta is cos square theta by sine theta. Okay, so looks good only. Cos square theta by sine theta looks good. Similarly, M. Tell me, children, what happens with M? Secant theta minus cos theta. How can we proceed?
Secant theta 1 by cos theta minus cos theta.
Very good. Secant theta is 1 by cos theta minus cos theta. Next step.
1
What's the
minus
common?
cos square theta by cos theta.
1 minus cos square theta by cos theta. Next step.
Secant square theta by
Sin square theta by cos theta.
Sine square theta, not secant square theta. Sine square theta by cos theta. So let's simplify like this. So the expressions which are given for L and M, let's work it like this. And now use these expressions to substitute. Okay. Okay. So that's what you see here. That's what you see here. L is equal to cos square theta by sine theta, and M is equal to sine square theta by cos theta. Just what we worked here. All right. Now take up the LHS. What's the LHS? This one. Write that here. We need to work this and get the answer as 1. We need to work the LHS and get 1 as the result. So this is the LHS. Let's substitute. Substitute very carefully. Very carefully. See here, you should write L and square it. This is L. This is L. Write that. And square it. See the square here. Then write M and square it. So this is M. This is M. See, we've written that here. And we have squared it. See here, the square. So that is about L square M square. Then in the bracket, you must write L square plus M square plus 3. So this is L square plus M square plus 3. Okay, so we have substituted. Okay, that's the first step. Now, next step. Whenever we have, see, this is what we normally do, you know, whenever we have like a by b the whole square or a square by b the whole square, you have to square this. You need to simply, that is simplification. You'll have to square this. So this will be a square, a to the power 4 by b square. A to the power 4 by b square. That is a square by b, the whole square is a to the power 4 by b square. All right, so you can see here, this will become cos theta to the power 4. You can see the square here and the square here. So 2 2s are 4. Cos theta to the power 4. And this one will be sine square theta. Sine theta the whole square. Sine square theta. The power 2 is to be applied to both the numerator and the denominator. So here also sine to the power 4 theta. And this one is cos theta the whole square, cos square theta. And it's a product. No, see here L square, M square. It's a product. L square into M square. L square outside, no, outside the bracket, it's L square into M square. It's a product. So see, I've written it like this. This is L square and M square. This is. Okay. Or if you don't want to write it like this, you can also, you see, if you don't want to write it like this, you can even write it like this, children. Cos theta to the power 4 by sine square theta. You can write it like this into sine theta to the power 4 by cos square theta. You can even write it like this. You can just put one multiplication sign in the middle like this. You can just put one multiplication sign like that in the middle. That's also fine. Like this. And in the bracket, this one again, see here, cos theta to the power 4, sine square theta, then sine theta to the power 4, cos square theta when you square it, plus 3, plus 3, plus 3. Don't get confused. You can just put one multiplication sign also in the middle like this. Now, very important. So take up the common denominator, sine square theta, cos square theta is common, take it up. And please understand that we have a sine square theta here. So we need to multiply the numerator by cos square theta. Listen to this very carefully. We have sine square theta. We don't have cos square theta here. So we need to multiply this numerator with cos square theta. Now it's like multiplying a to the power 4 and a squared. So when we have to multiply, we need to add the powers. When bases are same and it's multiplication, we have to add the powers, not multiply the powers. When bases are same and it's multiplication, we have to add the powers. So a to the power 4 into a square is not a to the power 8, is not a to the power 8. When bases are same and it's multiplication, we add the powers. A to the power 4 plus 2, a to the power 6. Similarly, law of exponents. Similarly, cos theta to the power 4 into cos square theta. When you multiply, cos theta is the common base. It's like cos theta the whole power 4 into cos theta the whole power 2. This is the meaning. So bases are same, cos theta, and it's multiplication. So we add the powers, 4 plus 2, 6. So it becomes cos theta to the power 6. That's what you see here, cos theta to the power 6. Similarly, for the next one, there is cos square theta. So we need to multiply the numerator with sine square theta. We need to multiply the numerator, this numerator, with sine square theta, sine square theta. We have sine theta to the power 4 here. Here the power is 2. Bases are same, sine theta, sine theta. It's multiplication. So add the powers, 4 plus 2, 6. 4 plus 2, 6. So sine theta to the power 6. And here there's only 1 in the denominator. So it will become 3 sine square theta, cos square theta. There's only 3 here, 3 by 1. But the denominator is sine square theta, cos square theta. But there's only 1 here. So multiply the numerator with sine square theta, cos square theta. So that will give you 3 sine square theta, cos square theta. Just as you take the LCM, children. So here we have taken the LCM. So this in the bracket we have taken the LCM, and this is what we get. Please remember. I'll tell you again. So if you have to simplify sine theta to the power 4 and sine square theta, if you have to multiply these two, it's nothing but sine theta the whole power 4 into sine theta the whole power 2. So it's like bases are same and it's multiplication. So we have to add the powers. So sine theta, add the powers, 4 plus 2, 6. So sine theta to the power 6, which is written as sine theta to the power 6 like this. And here what happens, you can cancel, no? See, this is cos square theta. So here it will be cos square theta. And then the sine square theta and this one. So here you will be left with sine square theta. Like you simplify a to the power 4 and a square and there's one a square left here like that. So this one, after simplifying, you get this. Here we have taken up the common denominator. Here we have taken up the common denominator. Now you can see here, there in the numerator we have sine square theta, cos square theta. Here also we have sine square theta, cos square theta. Gets cancelled. You can cancel them one by one also. You can sine square theta, cos square theta, gets cancelled. So we are left with these 3 terms. This one, and this one. Now this is of the form. These 3 terms are of the form a cubed plus b cubed. See, so much of algebra. All the identities which you have learned last year, no, in 9th standard, all those identities we'll use here in trigonometry and also in quadratic equations. Even in quadratic equations, we'll use a lot of identities, algebraic identities. So this is of the form, this is of the form a cubed plus b cubed plus 3a square b square, 3ab, sorry. This is of the form a cubed plus b cubed plus 3ab. So that a plus b is missing, into a plus b is missing. If it was there, if that into a plus b was there, then you can write it as a plus b the whole cubed. You can write it as a plus b the whole cubed. So because we know a cubed plus b cubed plus 3ab into a plus b. into a plus b. Is a plus b the whole cubed? Is a plus b the whole cubed? Now we have a cubed, we have b cubed, we have 3ab. We don't have a plus b. We don't have a plus b. If we had that, then you can write it as a plus b the whole cube. So what we do, see here in the next step. See, this is gone, children. This is gone. Now this one, we write it as something the whole cube. Listen to this very carefully. You need to see, how do you write a to the power 6 as something the whole cubed? You will write a square inside, right? Because 2 3s are 6. You need to multiply the powers here. When there are many powers, one base and many powers, you need to multiply the powers. See, children, how will you write? How will you write a to the power 6 as a perfect cube with a 3 outside? You need to write a square then here, because 2 3s are 6. Similarly, we have sine theta to the power 6, but you want to write it as something the whole cubed. You want to write it as something the whole cubed. That means you should write sine square theta here. Then only 2 3s are 6. So see here, the power is 6, put a 3 outside. So you'll have to take a 2 inside. The power is 6 here for cos theta. You're taking 3 outside. So it will be cos square theta inside. Then only 2 3s are 6. Similarly, sine theta to the power 6. You're taking a 3 outside the bracket, meaning whole power 3. So in the bracket, it should be sine square theta. 3 2s are 6. And write this 3 sine square theta cos square theta as it is. Now, how does it look like? This is A. This full thing is A cubed. This full thing is B. That means A is cos square theta. A is cos square theta. A is cos square theta. And B is sine square theta. B is sine square theta. See here, this is A. Cos square theta is A cubed. Sine square theta is B cubed. A cubed plus B cubed plus 3AB. See here, cos square theta, sine square theta. 3AB, 3 sine square theta, cos square theta. 3AB. 3AB. So we know that A cubed plus B cubed plus 3AB into A plus B. So what we do in the next step is we just add that term 3AB. 3AB into A plus B. What is A plus B? Sine square theta plus cos square theta. We just add it. We just include that because anyways, you're not making any change. What is sine square theta plus cos square theta? 1. So it's like you're multiplying by 1. That's okay. See here, because you have 3AB here. You don't have A plus B. So in the next step, 3AB into A plus B. What is A plus B? Sine square theta plus cos square theta, or cos square theta plus sine square theta. 3AB we have into A plus B. Sine square theta plus cos square theta. That's fine. You can write that, though it's not there, because anyways, it's 1 into 1. Now it's of the form A cubed plus B cubed plus 3AB into A plus B, which is A plus B, the whole cube. Cos square theta plus sine square theta, the whole cube. Because we know A is cos square theta. See, this one is A, cos square theta. This is B, sine square theta. So A plus B, the whole cube. This is A cube, this is B cube, this is 3AB into A plus B, which is A plus B, the whole cube. So cos square theta plus sine square theta, the whole cube. Now what is cos square theta plus sine square theta? 1. This is 1. Cos square theta plus sine square theta is 1. 1 cubed, which is 1, which is the RHS. Yeah, please write on, children. I'll give you sufficient time. Don't blindly copy. You're never doing that. You should never do that. Don't blindly copy. You're not trying to fill your classwork and, just have the notes like that on trigonometry. You need to understand what you're writing. Yeah. Please do that. You can just write this as cos square theta plus sine square theta. Right till here, And then I'll continue here, children. After this, please continue from here. Don't write this, children. Don't write this. Just written sign first and then cos. That's all. Nothing else. Same thing. I've just written sign first and then cos. Finish writing, children.
No.
Okay. Let me know once done. Yeah, children, done.
Yes, ma'am.
Yeah. So let's see the let's see the answer again. So first, we are given expressions for L and M. If possible, we can simplify. See, on when you work that further and you can get a simpler version, and that too in terms of sine and cos, be very happy. So first we take up the expressions given for L and M and we work it. So we convert cosecant theta to 1 by, or we write cosecant theta as 1 by sine theta. We write secant theta as 1 by cos theta, and we get, different expressions for L and M like this. Now take up the LHS, left hand side, substitute carefully. That's the first step. Then simplify. Whenever there are squares and other stuff, squares, cubes, you'll have to simplify. So like a square the whole square is a to the power 4. A square the whole square is a to the power 4. Multiply the powers. So like that, that's how you get this step. Just by squaring, just by, applying the squares to the numerator and denominator, you get this step. Then you have to simplify. See here, this one and this one simplifies to cos square theta. And when you cancel out these two, this becomes sine square theta. That's what you have here, sine square theta into cos square theta. That's what you have here. And here you'll have to take up the common denominator. Sine square theta, cos square theta is a common denominator. And I told you, when you have to multiply this by cos square theta, how do we multiply? When bases are same, cos theta is the base and its multiplication, you need to add the powers. The powers are 4 and 2. The powers are 4 and 2. You need to add the powers. Cos theta is the common base and the powers are 4 and 2. Add the powers. That's how you get the power 6. So do the same thing here. And here, since the denominator is 1, it's going to become 3 sine square theta cos square theta. Now write this in the form a cubed plus b cubed plus 3ab. So see, this is 3, this is a and this is b. So a is sine square theta, b is cos square theta. See a 3ab. What is a? Sine square theta. B is cos square theta. See what you're reading, 3ab. That means a is sine square theta, b is cos square theta. So see here, a, this is a sine square theta. A cubed, see the cube here. This is b cos square theta, cubed, b cubed, and 3ab, 3 sine square theta cos square theta. And you're not, you've just written, sine theta to the power 6 like this. 2 3s are 6. So in this step, we write the expression in the form a cubed plus b cubed plus 3ab. Now we realize that a plus b is missing. So next step, we simply write a plus b, sine square theta plus cos square theta in the bracket. And then you also realize that anyways it is 1, so you're not making any change. Because anyways into sine square theta plus cos square theta is into 1, which means there is no change. you've not made any change to the expression. So you can just add it like that, sine square theta plus cos square theta. Now it's perfectly of the form a cubed plus b cubed plus 3ab into a plus b, which is a plus b the whole cubed. So a sine square theta plus b cos square theta the whole cube. But we know that sine square theta plus cos square theta is 1. So 1 cubed, which is 1, which is the RHS. So you should know how to simplify the brackets when, squares or cubes are involved. That is one thing. Then taking up common denominator and using this identity. Because when you see the terms, they go with a cubed plus b cubed plus 3ab. And then you add that a plus b term. So this identity is very important here. I think the first one we finished. Yeah, I'm not explaining this to them. Please take down this. It's easy. First go through the answer. See, you can see m is cos alpha by cos beta. What will you do with that? What simplification can you do? M is cos alpha by cos beta. Nothing much can be done with that. So we'll take m as it is. And n is cos alpha by sin beta. Again, nothing can be done. So no simplification. We'll take m and n as they're given. Yeah, go through. First go through and then write down the answer. Done, children?
Yes, ma'am.
Right. Class, use the emoji. Raise your hand. Tarun Murali, Sashmin, Pranav, Ramnathan, Priyanka, Nandini, Ananya, Murli Krishna, Raja Rajeshwari, Harini, Sneha, Hitesh. I hope Netra is there. All right. So who can explain this to me? Okay, answer my questions. Can we simplify the expressions given for M and N further? It's a yes or no question. No, very good. We cannot simplify. So we should take up the LHS. This is the LHS. Okay. And then what should we do after taking the LHS? This is the LHS. Next step. Next step.
We should substitute the values.
Substitute the expressions given for M and N. So this is M square. This is N square. Next step. Next step, apply the squares. Apply the squares to the numerator and denominator. So that's how we get cos square alpha, cos square beta, cos square alpha, sin square beta, and this cos square beta outside. Next what, children?
Taking common. Cos square alpha.
Common.
Taken common.
Yeah, common. Cos square alpha is common. So bring it out. Cos square alpha is common. So bring it out. So we have 1 by cos square beta plus 1 by sin square beta and cos square beta outside. Next step. After taking common. Sorry? Common denominator. Very good. Common denominator. Sin square beta, cos square beta is a common denominator. So we'll have sin square beta plus cos square beta in the numerator. In the numerator, we get sin square beta plus cos square beta. What's the next step? How do we get the next step?
Identity.
Identity. Well, where?
Sin square theta plus cos square theta.
Yeah, very good. So sin square beta plus cos square beta is 1. So we write this cos square alpha as it is, cos square alpha. And this is 1. This one is 1. This one is 1. So you can see that 1 here, 1. And this, then what else? Yeah, then what else happens here in this step?
Cos square beta cancels.
Yeah, in this step, what happens is this one becomes 1. And then this and this gets cancelled. Cos square beta in the numerator and denominator gets cancelled. So we have to write cos square alpha into 1 by sin square beta. See, that's what happens in this step. You have to cancel, children. I cannot do that while typing, so I cannot do that. So you see it like this. So you have to cancel. You'll have to strike out this and this. You'll have to strike out this and this. So in this step, what we see is cos square beta gets cancelled. And this one becomes 1. This becomes 1. So you can see cos square alpha and in the bracket 1 by sin square beta. Yeah, next what, children? We need to get n square. We need to get n square. And what is n? Cos alpha. So you need to get cos alpha by sin beta the whole square. When you work the left hand side, you must get cos alpha by sin beta the whole square. That is equal to n square. So we are close. See, we got it. Cos square alpha, sin square beta. See here, cos square alpha, sin square beta. So it's like we have a square by b square. So next step, we write it as a by b the whole square. We have a square by b square. We have a square by b square. Next step, we write it as a by b the whole square. Cos alpha by sin beta the whole square. And you know that cos alpha by sin beta is n. So it is n square, which is the RHS. So we started with the LHS, we worked the LHS and we arrived with the RHS. Yeah. Very good, children. We finished this one. So this I've already explained, so I'm not doing it again. Take down this. This one. Take a screenshot, children. We have done this earlier. Please complete. Please work it again in your notebook. Please do it again in your notebook. Write the question and leave some space. You can gauge how much you need to leave, meaning how much space you need to leave in your notebook. Take down the question, all of you, and leave some space sufficient to complete this answer. So when you see that, at least you will know you will have to fill it. All of you, please take my instruction, write down the question. Yeah. Yeah, this is the next one. This is the next one. I want you to help yourself with this one. Take a screenshot. No, write the question. We'll discuss this in the next class on Tuesday. Please complete this in your notebook. See, again, using the identity, your work becomes very easy. A plus b the whole square minus 4ab is equal to a minus b the whole square. I'll explain this to you children on Tuesday. I want you also to think. It is easy. Understand and work it in your notebook. Written the question, all of you?
Yes, ma'am.
All right.
Yes, ma'am.
Very good.
Yes, ma'am.
Very nice, children. Thank you. So here, if 7 cosecant theta minus 3 cot theta is equal to 7, prove that, very important question. If 7 cosecant theta minus 3 cot theta is equal to 7, prove that 7 cot theta minus 3 cosecant theta is equal to 3. Right on, children? Yeah. So what you need to do here is, write down what is given. Write down what is given. You're given an equation. So you're given that 7 cosecant theta minus 3 cot theta is equal to 7. This is given to you. Now square this on both the sides. Square on both the sides. Square on both the sides. So this is like a minus b the whole square. What is a minus b the whole square? A square. That is, don't write anything, children. I'll show you the answer slide. Don't write anything. So this is a. What is a minus b the whole square? A square. A square. That is 49 cosecant square theta. Cosecant square theta. A square minus 2ab. So minus 2 into a into b. 2 7 are 21. 2s are 42. 42 ab cosecant theta cot theta plus b square plus 9 cot square theta is equal to 49. Is equal to 49. Now what you have to do is, you can see here in the equation given and what is to be proved. Here we have 7 cosecant theta. but here it becomes 7 cot theta. Here we have 3 cot theta, but here it is 3 cosecant theta. 7 cosecant theta becomes 7 cot theta. 3 cot theta becomes 3 cosecant theta. So what you need to do is, what you need to do is 49 into what is cosecant square theta? What is cosecant square theta, children? What is cosecant square theta? Identity. You can replace cosecant square theta with
1 plus cot square theta.
1 plus cot square theta. Very good, Ramanathan. 1 plus cot square theta. Minus, write this one as it is. Write this as it is. Then again replace cot square theta with, what is cot square theta?
1 plus cosecant square theta.
Cosecant square theta?
-1, ma'am.
Cosecant square theta minus 1. I think Tarun Murali, you said plus 1?
Oh, sorry, ma'am. -1.
-1. Cot square theta is equal to cosecant square theta minus 1. That's all, children. If you do this, you will get the answer. That's it. This is what you should remember. Because you can see here, 7 cosecant theta becomes 7 cot theta. 3 cot theta becomes 3 cosecant theta. So what we do is, to get that, what we do is, after we first square, we take up the given equation, we square it on both the sides. And we expand it. After that, instead of cosecant square theta, we say 1 plus cot square theta. Here, instead of cot square theta, cosecant square theta minus 1. Then, of course, you'll have to multiply. 49 into 1 is 49. 49 into cot square theta is 49 cot square theta. 9 into cosecant square theta. 9 into minus 1 is minus 9. Then again, you need to, I'll tell you. Yeah, start working. No, I think I'll tell you. Yeah. So then after, see, that will bring you till this step, till here. Now at this point, you see, you can see the numbers here, 49. You can see the -9, 49. Simplify all that. 49 on both the sides will get cancelled. 49, or you take everything to the other side. If you don't want to cancel it like this, what will happen? This 49 will come to the other side as -49. And then this -9 will come here as +9. So 49 minus 49, 0. And you can see this +9 alone here. The numbers are simplified. The numbers are simplified. See, there is a 49 here. There is a 49 here. So I cancel that. This -9 on the other side will become +9. +9. So now, children, this is what you will have. 49 cot square theta plus 9 cosecant square theta minus 42 cosecant theta cot theta is equal to 9. So now this is like a square plus b square plus minus 2ab. This is like a square plus b square minus 2ab. So write this as a the whole square, plus b the whole square, minus 2 into a into b, 2 into 7 cot theta, a into b, 3 cosecant theta. See, if you don't know what to write, just put an empty bracket like this and square. Just put a square. You must get 49 cot square theta. So 7 square is 49 and cot theta, the whole square is cot square theta. Put a bracket, empty bracket and square. 9 cosecant square theta. So 3 square is 9. 3 square is 9. And if you write cosecant theta here, cosecant theta, the whole square is cosecant square theta. So this is a square, a the whole square, this is b square. So you can see b the whole square and minus 2ab, minus 2 into this is a, and this is b is equal to 9. So you can see when you multiply 2 7s are 14, 14 3s are 42, 42 cot theta cosecant theta. See here 42 cot theta cosecant theta. So clearly it's in the form a square plus b square minus 2ab, which is a minus b the whole square. A minus b the whole square. A minus b the whole square. A is this one, b is this one. A minus b the whole square because it's minus 2ab. It's minus 2ab. So it will be a minus b the whole square. So 7 cot theta minus 3 cosecant theta, the whole square is equal to 9. So 7 cot theta minus 3 cosecant theta is equal to square root of 9, which is 3. Yeah, right on, children. Very important. I'll just come back, children. Please write. Done, children?
Yes, ma'am.
All right. Yeah, who can explain this? We'll do it together. So tell me. First, what? Take up the given equation. Then what's happening? Yeah, we square on both the sides. We square on both the sides. Okay. Then what is this like? This one looks like what?
A minus B the whole square.
A minus B the whole square. This one is of the form A minus B the whole square. 7 square is 49. This one is A minus B the whole square. So when you're squaring, be careful. 7 cosecant theta, it's not A square. It's not like this, children. It's not 7 cosecant square theta. See, A square. What is A? 7 cosecant theta. This is A. This whole thing has to be squared. This whole thing has to be squared. What is A? That full thing, whatever is A should be squared. What is A? 7 cosecant theta. This is A. This full thing is to be squared. So 7 square is 49 cosecant square theta. So it's not like this A square. So this is A and square. So put a square here. It's not like this. Whatever is A, that full thing, that entire thing should be squared. Similarly, B square. This full thing, this is B. This full thing should be squared. So 9 cot square theta. Okay, so this is expanding using the formula A minus B the whole square is equal to A square plus B square minus 2AB. Okay, children. Then in this step, what do we do? What are we doing in this step?
Take common out.
Take common out? No.
Identity.
Identity.
Yeah. Okay, identity. Yeah. We are replacing something by something. What are we replacing? We are replacing
Cosecant square theta with 1 plus cot square theta.
Yeah, we are replacing cosecant square theta with 1 plus cot square theta. And then we are replacing cot square theta with
Cosecant.
cosecant square theta minus 1. Then what should you do? You have to open up the bracket. When you have this, you have to open up the bracket. So 49 cot square theta, 9 cosecant square theta minus 9. And then this as it is and this as it is. Then some simplification. What? 49 on either sides will get cancelled. And this minus 9, it will travel to the other side as 9. Why we are taking it to the other side? Because you see a 3 here, no? So it will be square root of 9, which is 3. So take that number to the other side. Then what? Now this is in the form. The remaining terms are of the form A square plus B square minus 2AB. So you must show it's of that form. A square. See here, this is A square. When you square this one, you will get 49 cot square theta. This is B square. This is B square. When you square this, you will get 9 cosecant square theta. Minus 2AB. 2, this is A. Write this one A and write this one B. And when you multiply, you can see you will get 42 cosecant theta cot theta. See here, 7 2s are 2 7s are 14, 14 3s are 42 cosecant theta cot theta. See here. So clearly, meaning you're presenting this step. You're just presenting this step like this to show that it's of the form A square plus B square minus 2AB. We know that this is A square, this is B square, this is 2AB, but you must convince your teacher, no, that you've really understood. So you should present it in the form A the whole square plus B the whole square minus 2AB, which is A minus B the whole square. So A minus B the whole square is equal to 9. So A minus B is equal to square root of 9, which is 3. Maybe you can write the step if you want. So 7 cot theta minus 3 cosecant theta is equal to square root of 9, which is 3. Sorry, children, just a minute. Just a second, children. I'm not finding that file. 1 minute. Yeah. Sorry. Yeah, we'll just wind up with this one, children. I'll explain this, and then maybe if we don't have time, you can take a screenshot and complete this. Yeah, just explain this one. So here we are given if cosecant theta plus cot theta is equal to x, then find x square minus 1 by x square plus 1. See, instead of the question being then show that x square minus 1 by x square plus 1 is equal to cos theta. Instead of giving you like that, see, we get x square minus 1 by x square plus 1 is equal to cos theta. We get x square minus 1 by x square plus 1 is equal to cos theta. So instead of, the question being like this, if cosecant theta plus cot theta is equal to x, then show that x square minus 1 by x square plus 1 is equal to cos theta. Instead of giving you the question like this, it's put in this way. If this one is x, then find x square minus 1 by x square plus 1. All right, so we need to find this one, right? We need to find this one. So you can see here x is given to you. So take up the LHS. Take up the, oh, sorry, not the LHS. So take up this expression x square minus 1 by x square plus 1. X is given here. And we're not, see, now you might have a question like, now why you're not changing cosecant and cot to sine and cos? Good question. But cosecant and cot are connected through the identity. And you can see it as x squared. That is, this one is going to be squared. And when you square this, you will get cosecant square theta, cot square theta. Cosecant and cot are connected through the identity. Cosecant square theta minus cot square theta is 1. So we won't disturb them. So we will not disturb them. You will also believe that much more as we understand the answer. So don't disturb cosecant theta and cot theta because they are connected through an identity. Cosecant square theta minus cot square theta is 1. For that reason, we don't disturb this. We won't disturb this. Let it be as cosecant theta plus cot theta. We'll not change it to sine and cos. So now take up this expression x square minus 1 by x square plus 1. So this is x square minus 1, x square plus 1. So that's the first step. Substituting for x is the first step. Then, of course, we have to expand. This is like a plus b the whole square, and this is also a plus b the whole square. So expand a square plus b square plus 2ab, a square plus b square plus 2ab. So simple, minus 1 plus 1. That's the next step. That's the next step. So you have to expand, right? So that's the next step. Now, what you have to do is, now wherever you can use the identity. Now you know that cosecant square theta minus 1 is cot square theta. Cosecant square theta see, cot square theta minus 1. Okay, let me write. Cosecant square theta minus cot square theta is equal to 1. All right, this is the identity. Cosecant square theta minus cot square theta is 1. Now, if you group cot square theta and minus 1, it will not help you because 1 plus cot square theta is cosecant square theta. 1 plus cot square theta is cosecant square theta. But here you have cosecant square, sorry, we have cot square theta and minus 1. No, there's no point grouping them. But you can group cosecant square theta minus 1 because that is cot square theta. Group cosecant square theta and minus 1 because that is cot square theta. So see, cot square theta minus 1 is not going to give you anything. You write the identity and see. Cot square theta minus 1 will not give you anything. So group cosecant square theta and minus 1. Cosecant square theta minus 1 in the bracket. Write the remaining as it is. Cot square theta and this one as it is. And in the denominator, cot square theta plus 1 is cosecant square theta. See here. See here. cosecant square theta minus cot square theta is equal to 1. So if you group cot square theta plus 1 in the denominator, what is 1 plus cot square theta? Cosecant square theta. So group where you can use the identity, that's all. Here, if you group cosecant square theta minus 1, in the next step, you can write cot square theta. In the denominator, cot square theta plus 1 is cosecant square theta. So like that, we, group them. So cosecant square theta minus 1 in a bracket and write these two terms as it is in the numerator. In the denominator, this one you write it as it is. You can group this and this. Cot square theta plus 1 is cosecant square theta. Write this one as it is. In the next step, so using the identity, this is cot square theta and this cot square theta as it is, and this one as it is. And in the denominator, this as it is. This one is cosecant square theta. This one is cosecant square theta. This one as it is. That's the next step. Then see, once you do that, no, see, this will take you to the next step. What will you do? Cot square theta plus cot square theta, 2 cot square theta. Cosecant square theta plus cosecant square theta, 2 cosecant square theta. Like a squared plus a squared is 2a squared. A squared plus a squared is 2a squared. Cot square theta plus cot square theta. A squared plus a squared, 2a squared, 2 cot square theta, 2 cosecant square theta. And write this and this as it is in the numerator and denominator. Now the golden rule, whenever there's something common, we take out the common factor. And there is something common. 2 is common and cot theta is common. 2 cot theta is common in the numerator and 2 cosecant theta is common in the denominator. Bring out the common terms. So 2 cot theta is common in the numerator and this one is common in the denominator. And then what will happen in the bracket? 2 cot theta into cot theta is 2 cot square theta. And 2 cot theta into cosecant theta is 2 cosecant theta cot theta. In the denominator, 2 cosecant theta is common. Into cosecant theta is 2 cosecant square theta. And this one into cot theta is 2 cosecant theta cot theta. So this is what is common. This is how we take out 2 cot theta, 2 cosecant theta common and get these terms in the bracket. Okay, so now you see that cosecant theta plus cot theta, cosecant theta plus cot theta, they're the same. It's like b plus a here and a plus b here. You can cancel it out. This is cot theta plus cosecant theta. This is cosecant theta plus cot theta. They're the same. You can cancel them out in the numerator and denominator. And also 2 cancels. So you're left with cot theta divided by cosecant theta. Cot theta divided by cosecant theta. You're left with this. Now what is cot theta? Cos by sine divided by what is cosecant theta? 1 by sine. So now cos theta by sine theta into reciprocal. Division becomes multiplication. Reciprocal of 1 by sine theta is sine theta. Sine and sine gets cancelled. Cos theta. So the value of x squared minus 1 by x squared plus 1 is cos theta. Very important. You have the same thing in terms of secant and tan. We'll do it in the next class. You will be given secant theta plus tan theta is, x or y. We'll see that in the next class. Yes, children, since it's time, please take a screenshot and complete this. Very important question. These are standard ones. If asked, it will be asked like this only, without any changes. These are standard questions. If it appears, it will appear like this only. There'll be no change in the question. Taken a screenshot?
Yes, ma'am.
Yeah, please. I think we have about 3 to 4 answers to complete. Please finish it. Do not forget. Please complete it.
Yes, ma'am.
Yeah, good. All right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call.